In this video, I'm going to go over the basics of probability. Firstly, what is probability? It is defined as the measure of how likely an outcome is to occur. So if I want to assign a numerical value to tell me how likely is this to happen, I can do that with probability. The probability of an outcome that is certain to occur is 1 or 100%, and likewise, the probability of an outcome that is certain to not occur is 0 or 0%. Something that is likely to occur but not certain to occur will be in between 0 and 1. To give you a real-life example, the probability of my hair to be black is 1 or 100% because I am certain for this to occur. The probability of my hair being blonde is 0 because I am certain that this is not going to occur. It can be used to predict an outcome to happen before it happens, and it is seen in many real-life situations, such as weather forecasting, coin flips, and dice rolls, the latter of two examples that we are going to be exploring in this video. It is likely that you already use probability but just don't know it to predict what may happen in the future. Let's take a look at probability scenario 1, a coin toss. If you toss the coin once, the probability of getting heads is 1/2 or 50%, and it's the same for getting tails, assuming that tails and heads are the only things that you can get. With two flips, there are 4 possible outcomes: 2 heads, heads then tails, tails then heads, and 2 tails. Now, out of these 4 scenarios, only once can you get heads twice. So the probability of getting heads twice is 1 out of 4 or 25%. The same thing is true for getting tails twice. But out of these 4 outcomes, the probability of getting heads once and tails once is 1 out of 2 or 50% because out of these 4 outcomes, it occurs twice. What about 3 flips? Try to think about making a tree diagram as shown here, which may tell you each of the different possible outcomes so that you can determine the probabilities. Let's take a look at probability scenario 2, dice rolls. Now, the probability of getting a 6 when you roll a dice is 1 out of 6. It's the same for getting any specific number. It's always 1 out of 6 for an unbiased dice. Now, what about 2 dice rolls? The probability of getting 2 sixes is 1 out of 36 because to get the first 6, that is a probability of 1 out of 6, and to get another one, you also have a probability of 1 out of 6. So multiplying those 2 fractions, you get 1 out of 36. The probability of only getting 1 6, you'd have to figure out by getting 1 6 first, which has a 1 out of 6 probability, and then not getting a 6, which is a 5 out of 6 probability. So multiplying those 2 fractions together gets you 5 out of 36. The probability of getting no 6s is 25 out of 36 because to get no 6 on the first roll, you have to get 5 out of 6 probability, and then the next roll also 5 out of 6 chance that you won't get a 6. So multiplying those 2 fractions together gets you a 25 out of 36. The sum of values from 2 rolls, so if you roll 2 dice and you add the numbers that show up, you're most likely going to get a 7 and least likely going to get a 2 or a 12. Take a look at the diagram shown on the right. There's only one scenario when you get a 2, where you get 2 1s, and there's only one scenario where you get a 12, when you get 2 6s. But there are 6 different scenarios when you can get a 7, so therefore, getting a 7 is the most likely option. This is shown in games like Monopoly, where you may have to roll 2 dice. In these games where you have to roll 2 dice, you are most likely going to get a 7. Have a look at these extension questions. These are questions that use the concepts that we've covered, but to a greater extent. If you have any comments, queries, concerns, please feel free to leave a comment down below. I hope you found this short video worthwhile, as the purpose of it is to frame the subject in a thought-provoking way.